Hello friends, today I'm going to talk about Leetcode 331 verify pre-order serialization of a binary tree. The problem is that you are given a binary tree with pre-order serialization. How it is serialized it is this example, and given that a binary tree, we know that the pre-order starts with 9, 3, 4, and then with this sentinel value pound and pound, and then 1 pound pound, and 2 pound 6 pound pound. So now the problem is that we are going to find whether it is a valid serialization given a string of this serialization. And for this example, you can see that it's true if given in this order. And for this second example, it returns false because it is 1 and pound, and it's not valid. The valid one is 1 pound and pound. So let's consider how to solve this problem. And we know that for we can, and first we need to formula with the preorder. For the preorder, it starts from the root node, and then the left child node, and then the right child node. So for here it starts from 9, and then the left pound and the right pound. And if it's given in this order 9 pound pound, we can see that we should return true, right? And if we again given this pound 9 pound, we should return false because in this order pound 9 pound is not a valid tree serialization. And let's consider another example. For example, here is 9 and pound and 4 pound and pound. For example, if it's given this order 9 pound, no, this 9 pound 4 pound pound. We know that this is the corresponding to this tree, so it will return true here. And from this we can see that with preorders, because every root has 2 children, so we can see that when we use preorders, we use root and left and right child. So we can use this formula, we utilize this principle to find out whether it's valid or not. So we can use a stack to get it here. If every time we find that there are 2 pound together, that is in the stack there is a pound, and the current value that we are traversing is also a pound. In this case, we need to pop from the tree, from the stack. Other cases, we put into the stack of the current value. And let's give an example for this 9 pound. And first, if it's if the stack is empty, and we know the stack has no pound, so if we put the 9 into the stack, now the stack has 9. And for the second iteration, we we check that the stack has no pound, we put the pound in it. And for the third iteration, and we know that the current is pound, and we check the stack, the stack top value is pound. So then we pop from the tree stack. We pop from the stack, and also we need to pop again if the stack is not empty. We pop again. Why do we need pop again? Because for every node that has two children, left and right. So here we find this sharp pound and this pound. So we have to pop its left and also the root node. And after that, at the end of the iteration, we put the pound in the stack. So finally, if we return the stack is not empty and stack the last element equal to the pound. If in this case we return true. Okay, let me give another example. Use this 9 pound, 4 pound. We know that first we put a 9 in the stack for the first iteration. For the second iteration, we put a 9 and pound in the stack. And for the third iteration, we put a 9 and 4 and 9 pound 4. Because this also still not satisfied. If and else for this case, we put all. For the fourth iteration, we put the 9 sharp pound 4, and also because the top stack is not pound, so here should be the if the stack top is pound. And after that we put 9 and we get the current is pound, and also the stack top is pound. So we should pop from the stack. Now we pop this pound and also pop 4 because the stack is already empty, and because also we need to pop continue to traverse again. Use a loop. So here we should use a while loop for this one. If it's still is here should be a while loop, not if, while. And then we pop from the stack. And now we need to continue to pop from the stack because stack is not empty. So now here is that, and then at the end we put the stack of the current. So here should be not else, should be just the end. So finally this should be the pound. Then we return stack -1 is a pound. So we return true here. So the final idea is that we use for every element in the preorder, and we call this process in the for loop. So we can get whether it's is valid. Actually, there's also another solution we can. The second solution is that we have found that for every root node there has two children node here. For example, here is 9 we can see that it has one real node and also two non nodes. And for this valid option, we know it has two real nodes and three non nodes. And for this example, we can see that how many real node 1, 2, 3, 4, 5, 6, 6, right? For how many sentinel values here? 1, 2, 3, 4, 5, 6, 7, right? In 6, 7, and 6, and also 7. We can see that the null value has one more than the real node. So whether we can utilize this pattern to solve this question? Yes, or we can utilize, but we cannot just get the count and figure and judge whether the null nodes is one more than the real nodes. That doesn't work. So we have also need to follow the orders, and we can define of the counts, the total counts the difference between the real nodes and null nodes. So every time if we encountered a real nodes, we count and plus 1. And if it's real node, and if it's pound, we minus 1. So in this way, then we can see that we can initialize the counts at 1 because we know that now node has one more than real nodes. So finally, we check whether the return the what should we return? We should return the count equal to 0. If it's 0, we return true here. Like for this example, first we count traverse none. When traverse none, we get its count equal to 2 because it count initialize as 0 as 1. Sorry. And then if we encounter the sharp and we get the count equal to minus 1, so it's now equal to 1. And next we get the 4, we get count equal to 2. And next we encounter the pound equal count minus 1, so count now equal to 1. And then we get a pound again, so count minus 1 equal to 0. Now we return count equal to 0, so we return true here. So this is the idea. So we do not need to use the stack. No stack used. Now let's write the code. So I'm gonna to write the code with stack. And first we consider some corner case. If the preorder is empty, we return true here. And then we define we have to get the nodes because it's a string. We can get each element. So node is equal to preorder use split comma, and then we define the stack. And we traverse each node and element get the index and the element here. And if the node equal to node equal to, we have to use a while loop to double check whether the current stack is empty or not. Stack is not empty, and also the current element is pound, and also the stack and stack top is pound. Only the three conditions are satisfied, we can see that we need to pop from the stack. And if stack is not empty, we continue to pop two elements, because as we know the property that a root node has two children. If otherwise, that means empty, so we can return that false because it will be invalid. And we know that current weight is not the preorder. Current element is still not finished, but the stack is empty. That means that we have something wrong with that during the process. So we return true false here, and after that we put the element in the stack. Yeah, we return where the stack equal to 1, and also stack 0 equal to pound. Okay, let's continue to run the code. Okay, we made it. Thank you very much for watching. See you next time.